All right, counting principles. No, we're not counting, Mrs. Miller, Mrs. Whitehead. We're not counting principles that way. These are PLE principles. So what we're going to be doing here with this subject is we're going to do some simple counting problems. We're going to use fundamental counting principles to solve more complicated counting problems. We're going to use permutations and combinations. Say what? This is going to be a blast. We're going to show you how to do that with and without your calculator, because I don't know, somebody may someday just have to give you a problem with where you cannot use your calculator. I know it'd be mean if somebody did that. I'm not saying someone would, but okay. Well, here's a simple counting problem. What that means is whenever we try to find probability, there are a lot of different, probability is the way you can find different number of ways an event can occur. So we're going to do a simple counting problem here for example 1, where we're going to select pairs of numbers at random. So what we need to do is it says determine how many ways a computer can randomly generate two integers from 1 to 12 whose sum is 6. So if you think about choosing two numbers, then what we're going to do is we're going to say we have our first number and we're going to have a second number. So if we are choosing our numbers that sum to 6, well, that automatically takes anything out that is bigger than 6. So if we list, actually say your first number, say we list all these out. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So say you have those numbers, because it says you can choose integers from 1 to 2, 12, not including negatives. Well, anything that's bigger than 6 is automatically out, because you can't sum a bigger number to get a smaller number unless you're using negatives. And then would 6 count though? Because if you have your first number as 6, and then if you have 6 plus what gives you a 6, well, you'd have to have a 0. Well, 0 is not going to be an integer in this case. So 6 is also out. So in order to figure out how we could find a sum of 6 for your second number, if your first number is a 1, then you would have a 5 to find a total of 6. 1 plus 5 gives you a 6. If your first number is a 2, then to get a total of 6, you'd have a 4 for your second card. If you have a 3, then your second card must be a 3. And if you have a 4, then your second card must be a 2. And if you have a 5, your second card must be a 1. So what that does is you can't use any of your numbers bigger than 6. You can only use 1 through 5 of both cards. So if we add these up, you have 1, 2, 3, 4, 5 different ways to find a total of 6. That is a simple counting problem where you just list out your possible ways and then try to figure out how you can actually find a specific